Hey guys, Tan Hao over here, and today I'll be going through lesson 1 of my Python coding course. It is completely free of charge, and yeah, this will be the rehearsal for the actual live presentation. So this is the agenda for the first few lessons, and I'm not sure if I'll be able to do lessons 4 and 5, but and so on. But in lesson 1, we'll be covering variables, lists, and for loops. Okay, so first of all, what is Python? It is a programming language that is, I feel, and most people think that is the easiest to learn for beginners because the syntax is simple. It doesn't involve a lot of brackets and keywords that are daunting the for somebody trying to learn how to code. So overall, programming is about using logic to tell the computers instructions or procedures for it to execute, and it will happen line by line, and we'll see an example of this later. So there's no secret to there's no limitation to the amount of resources that are available online also, because personally I've learned coding from this YouTube channel, The New Boston, and I highly recommend you check it out if you want to learn coding. But besides content, which is in my opinion freely available online, there's also a need for you to practice. So that's where hands-on experimentation will come in, because the content can only it's sort of like a theory, but in order to actually learn how to code, you need to go hands-on and try to code by yourself. And only through experimentation will you realize that there's some things that you actually are not so familiar with, and that is where the real learning happens. So just to show you, this website, rpl.it Python, I'll send it in the description below. It's basically a website where you can type Python code in. So you can type a few lines here, and then you can click run. In this case, it's not a valid line of code, it's just gibberish, but yeah, so you can type lines of code here, which will be executed sequentially, and the output will be here. And in addition to this area where this text box where you can write code and they'll execute it for you when you press this green button over here, you can also type code over here. So for example, I type this is called variable, later we'll see, and you can type code one line by one line over here, and it will be executed, and the output will be printed immediately. So this is my the one with the yellow arrow is my input, and then the next line will be my output once I press enter. Yeah, so and there'll be also another website that I will put in the chat because this is a website that I designed that is basically a virtual classroom where both you and I can edit the code together. So in the case where you meet a bug or you need help, right, you can use the help button to get my attention, and I will get to you and help you debug, and you'll be able to see the changes on your editor as well. So basically it's a Google Docs part for coding, and it also has a built-in Python um, Python Python compiler, not really compiler, Python program. Yeah, so first, without further ado, let's jump right into the first concept, which is variables. So variables is okay, so you might have heard of variables in math and in coding, right? I mean, you might have heard of variables in math, but let me just tell you, it's very different, okay? Because in math, variables, they are unknown, they represent an unknown value. For example, you have the equation x squared plus 2x plus 1 equals to 0, and you don't know the value of x. So we go through some arithmetic manipulations to obtain the value of x. In this case, x equals to minus 1. So this is the notion of variables in math, but I need you to forget about this notion completely, because variables in coding are completely different. Variables in coding are containers of information. So yeah, we'll see a hands-on example of that later. So if we take a look at the code over here, so let me just clear the console. Okay, so let's say we type x equals to 5, right? This tells Python to create a variable named x, right? So this is the variable name on the left, and you write equals. This is assigning the variable the value 5. So when I press enter, there's no output at the moment, but there has been some changes to the variable x. So if I go ahead and print x right now, so if I want to find the value of a variable, I'll write print, and I'll open the bracket and close the bracket, and in between I'll sandwich the variable name. So in this case my variable name is x, so when I press enter I will see 5 as the output. So in essence, variables in coding are containers of information, right? They can store numbers, they can store words, and they can store a lot more. Yeah, later we'll see variable types, but they are containers of information, and when you can store values in them. So currently it looks like there's not much difference between variables in coding and in math, right? But actually there's quite a huge difference. Okay, because if we take a look at some example code over here, you'll see that first of all, in the first picture over here, we see that variables can be overridden. So for example, we write y equals to 3, right? So we created a variable named y, and we assign it the value 3. Okay, so if you go ahead and print y, we expect 3, just like the previous example. But if we go ahead and write y equals to 4.15, then we print y again to find out the value stored in y, then we see that it has now changed to 4.15. And what this first example illustrates is that variables are containers of information, and what they store can be replaced by code. So when you write this in the first 2 lines I wrote y equals to 3 and print y. Currently the variable y stores the value 3. Okay, but after that, when I write y equals to 4.15, the new value 4.15 replaces whatever value was in y. So now y has immediately forgotten about 3, right? It's like it was never even 3 in the first place. It has no history. It just completely forget that it stored the value 3 ever. And now all y stores is the value 4.15. So if I go ahead and write y equals to 6 now, it will replace the value of 4.15, and the value of y is now updated to be 6. Okay, so the first example here illustrates that variables are containers of information, but how they differ with math is that instead of representing an unknown value, an unknown fixed value that doesn't change, variables are containers of information that can be actively replaced with new values. So yeah, so they can be they are mutable, right? Variables can store a value at this time, and then after some time has happened, it can store another value. So they are really like the boxes of information, containers of information that can be replaced. So that's very important, first concept of variables. And yeah, that's really the main essence behind variables. So what is interesting to note is that variables, because they store information, okay, let's write a few lines of code. So let's write x equals to 1. So we'll take a look at the second picture over here. X equals to 1, we write print x, we get 1 just as expected. But let's say I write the line of code x equals to x plus 10. Okay, I press enter. You see that Python hasn't complained, it hasn't thrown an error. And in math, right, this x equals to x plus 10 would completely not make sense, because there's no such value of x that satisfies this so-called equation. But what you must note in Python is that this actually completely makes sense in Python, because the equal sign here isn't asserting equality between the left hand side and the right hand side. The equal sign here is telling Python to assign the variable on the left the new value of whatever is on the right hand side. So right now, if I print x, you'll see that it is actually 11. So what has happened in this x equals to x plus 10 line of code here is that we're saying, okay, initially at first we wrote that x equals to, at first we assigned the value 1 to the variable x, right? So then x stored the value 1, and then in the next line of code over here, we're telling Python, okay, I want you to replace whatever value was in x with some new value. And what is the new value? This new value is the right hand side. And what is the new right hand side? The new right hand side is x plus 10. So Python will retrieve the value of x, right, which is 1. So the right hand side will be 1 plus 10. And hence, the right hand side equals 11. And we are telling Python to assign the value 11 to the variable x. So what the lesson for this second picture over here is that the equal sign in coding is not an assertion of equality. equal sign in coding is a assigning of a new value, which is the right hand side, to the variable, which is the left hand side. Yeah, so then we take a look at the third picture over here, and we try to execute x plus 1 equals to 3. We see that it fails. It says cannot assign to operator. Basically, what this error is saying is that the left hand side is not a variable, because x is the variable, but x plus 1 is not a variable. So while this line of code might make sense in math, right, because x plus 1 equals to 3, you just get x equals to 2, but this line of code doesn't make sense in coding in Python, because um, because in Python the equality sign once again is an assigning operator. It is not asserting equality, but it is saying assign the left hand side variable the new value of the right hand side. And in this case, x plus 1 is not a valid variable, yeah, because there's a plus 1 over here. So that's the key differences between variables in coding and in math. So I hope that that's clear. So other than that, that's actually the main I would say that actually this second picture over here is the main um, mental blockage that people meet when they first learn variables. So as long as you get that the second picture over here, how it makes sense, you essentially have gotten variables, because the rest of them they are quite simple. So this is the main conceptual roadblock that you need to get over when you first learn coding. Okay, so let's go ahead, and so let's create a few variables, and it turns out we can do arithmetic variables as well. So let's create a variable named a with the value 10 and a variable named b with the value 2. Okay, so we can just do arithmetic with it. So let's say we write print a over b. So this will just we're printing the value of a over b. What is a over b? Is 10 over 2. Press enter, we get output 5. Okay, then we can do more arithmetic. For example, we can write this one is called creating a variable called area equals to pi times radius, which is, yeah, so this is just more arithmetic variables. And on the bottom picture over here, we see that we can also use the brackets and multiplication, and it follows the order of operation that we see in math as well. Okay, so yeah, okay, when you don't write a print statement and you just have an output, Python still outputs the variable, but yeah, if I wrote a print statement here, it will behave the same way. Okay, so here's a checkpoint. We create a few variables, and let's see what the output is. Okay, so yeah, so I encourage you to open this editor, right, REPL Python 3, this link. Okay, I'll put it in the chat, and yeah, and go ahead and run the code. So when you want to clear the console, you press this X over here, right? Okay, for now we'll leave this top console alone. We'll not be touching it, but later we'll be touching it. But over here we'll be writing most of our code over here. So we press the X button to clear the console, and we press enter to get this green this arrow that we can start writing code in. So yeah, let's start. So we create a variable named a with the value 10, we create a variable named b with the value 4, create a variable c with the value 2. So right now all these they store values. All these variables, they store values, right? And when we assign b equals to b over c, so remember, what does this line of code mean? Is that we're assigning the variable b, right, with the value of b over c. So what is b over c? B over c, take a look, the value of b over c is going to be 4 over 2. So if you print b, we're just going to get, because we have assigned the value b equals to 2, so we print b, we just get 2. Okay, so then let's do another line. So we write b, we try this out in your editor, and I encourage you to. So in the next line, we write b equals b times a minus 3. So what would this output? So this outputs 17. And why is that so? Because the current value of b is 2, right? So when we go to the next line, we see that essentially the right hand side is writing a equals to 2 right, which is the value of b, then what is the value of a? The value of a is 10 at the moment. So 2 times 10 and you minus 3 and that is 17. So yeah, so when you print a, this line of code is just assigning a equals to 17, and when you print a, that's why you get 17. So simple enough, I hope. And yeah, so one small note is that variable names, you can name your variable any name you want, but there are a few rules that you must follow. So for example, you cannot create a variable name with a space in the name. So on the left hand side is the variable name, right? If I type my variable equals 2, that's invalid because you cannot have spaces. Okay, but you can have underscores, so that's how that's a convention that most programmers follow. Yeah, so then if I print my variable, then I get the value 2. So if you want spaces, the convention is to use underscores instead of that. Yeah. So another thing to note is that variable names are case sensitive. So you see this case, in this picture below, we have a variable called my variable with all small letters, and the next line over here, we have a variable called my variable with capital V. And if we print those two values, you realize that they have different values. So these two containers, they are not linked in any way. These two variables, they are different variables. Yeah, so it's case sensitive. So yeah, just note that. Okay, so now I want you to give it a try, and we'll be going through this code in a while. Okay, so yeah, for viewers at home, I invite you to pause the video and give it a try right now. I'll be going through in 3, 2, 1. Okay, so the first assignment here is to can you create a variable called area and assign it a value of pi r squared. So okay, let's go ahead and try. So we have a variable called radius and we assign it the value 5. A variable called pi, we assign it the value 3.14159265. Okay, so what we need to create a variable called area. So that's our variable name, and we need to assign it value. So we use the equal sign to assign it a value. And what is the right hand side? We want to assign it to pi times radius times radius. Okay. Alternatively, if you want to do the exponential, some of you might have tried something like that, and then you see there's an error because this power thing is actually not a thing in Python. It kind of is, but we'll get on to that later. It actually represents XOR. So in Python, the exponential is denoted by this double times sign. So we write this, we see the area has been assigned the correct value. Okay, so that's the first exercise. I hope it's okay. Damn it, I keep opening my email. Sorry. Okay, so then the second exercise, we need to predict the following output. So what is it? Okay, so yeah, so in this case, okay, so I forgot to talk about it, but you see that over here, one way to do it is to write area equals to pi times radius, right? Another way is, let's say we create a new variable called r squared equals to radius and radius, and then we write area equals to pi times this variable in line 3, and that's completely okay as well. You are free to create as many variables as you need to achieve a certain task in programming. And these are, you see, there's two different code that works, right? This one and this one. And in coding, we say that there's two different implementations of the same behavior. So you see that to achieve the same task, there's many different implementations, right? And many different ways you can do it. So there's no one right answer in a sense. And that's also where majority of code design comes in. You can write a code that is very hard to read for others and behaves very difficultly, like it cannot be easily debugged, or it's hard to spot errors. Or you can write a code that is very neat, and once people see it, they understand what's going on. So yeah, more on that when you go into coding in more seriousness. So okay, so exercise 2, let's predict the output. So a equals to 8, b equals to 64, a equals to b over a, which is 64 over 8. So you print a, you get the value 8. Okay. Oh, I forgot to mention, I think you might have been confused. Yeah, okay, so the code over here you see in this picture is the one written in this editor over here. So actually the editor works the same way as the console, in that in the console you write lines of code one by one. So write things like that, and then you write things like that, but in the editor you kind of write all of them at once. So you can write a equals to 8, right, and you press enter, but you don't see an output immediately because it's the editor instead of the console. So you can do the exact same things. Both basically the console over here is just executing code line by line, whereas the editor over here allows you to write multiple lines of code, and then when you press enter, it will execute. You go from line 1, then you go to line 2, execute it, you go to line 3, execute it, you go to line 4, execute it. So this is just a way where you don't have to keep on entering the same commands or something. Yeah, so okay, so anyway, back to it. So then print a, we get 8, right? So then if we write a equals to b over a again, we print b. So what is the value of b? Well, a has changed, but actually b hasn't. So b, you press and you run this code, this print a will still output 8, and print b would output 64 because b hasn't changed ever since. B hasn't changed ever since this line. Okay, so then we go on. So we write b equals to a times 10, right? And then a equals to b over a, and print a times b. So okay, so after this line, after this line b has the value 640. Then we write a equals to b over a, so 640 divided by a. What is a? Okay, so let's write a few comments. So if I use the hashtag sign, it means that these are called comments. So basically whatever is after the hashtag sign, it doesn't run. Okay, so this is for you to like document. You can write stuff here to explain your code and stuff. So right now over here, a has the value 8, right? So this prints the value 8. Then now a has the value b over a, so it's 64 over 8 is 8 again. Okay, so this is print b, so this prints 64, b equals to a times 10. Oh sorry, it's not 640, it's actually 80. So now b has the value 8 times 10, which is equals 8 times 10, which equals to 80. And then here a has the value 80 over, what is the value of a? The value of a is 8, so value of 8. So then in this case we are printing so a is now 10, and now we're printing 10 times b, 80, and hence we get the value 800. So we print, we get the value 800. So we're just basically playing with the reassigning of variables. And yeah, I hope it hasn't gotten too confusing. So anyway, lastly we write a equals to 3, and we print a, and we get the value 3. So yeah, so we write these lines of code, right? This line of code, we write this line of code inside the editor, right? Then you're gonna get the output shown here. Okay, so yeah, so last exercise, x equals to 5, x equals to x plus 1, so now x is 6, right? X equals to x over 2, so now x is 3, x equals to x times 3, so that now x equals to 9, and lastly x equals to 27 over x, so now x equals to 3. Print x, just get 3. So these two examples on the right are just for you to get comfortable with the idea of reassigning the new value to the variable, yeah, and replacing whatever old value was there. Okay, so I hope that the concept of variables is clear enough, and as long as you understand the concept of reassigning, yeah, that's pretty much all there is to variables. So yeah, So anyway, let's say we want to have many variables, right? And let's say we want to have many variables. So let's say we want to have 26 variables. So you can use the letters A to Z. But is there a more efficient way to create many variables? And the answer is yes. And it's called lists, or in other programming languages, it's called arrays. So what is a list? A list is, as it implies, is a list of values. So instead of just storing one value, right, a list can store multiple values. And how it does so is it creates a table of sorts where you have, yeah, it creates a table of values. So for example, if we just go through the syntax first. So let's clear the code over there. So let's create a list called myList equals to, and to create a list, you put square brackets, right? And inside the square brackets, you put the values that you want to store. So there'll be, let's say I want to store four values, 1, 5, 2, 3. So instead of creating 4 variables and having 4 variable names to keep track of, I just have one list name, and it stores all 4 variables like that, separated by commas. So you press enter and I print my list. What does Python output? It outputs the list. Okay, it's okay to have spaces between the values. It's just to make it look nicer. So yeah, so how do I access? So of course storing many values is good, but how do I, it's not useful if I cannot access them, right? So how do I access a particular value? So let's say I want to access the first value, which is 1. So we go through something called indexing, right? So if this is my list represented in this table by 1, 5, 2, 3, then associated with the list, right, tied to the list, there's something called index. So the index is the first variable be index 0, and second variable index 1, and so on. So so yeah, you may be wondering why it starts from 0, and right now you can just take it as it starts from 0. So yeah, that's just a rule that you can remember. So it starts from 0. So the first value, you want to access the first value, you go through index 0. So how do you access an index? So you let's say I type print, and inside these parentheses I want to type to access the value. I want to get the value of the first value, right, which is index 0. So I type the list name, and I open square bracket, close square bracket, and inside the square brackets I sandwich the index. So let's say I want to access the first element, which is index 0, so I use 0 over here. Okay, so I press enter. You see that it successfully accessed the first value, index 0 of this list, which has the value 1. So I can access the other values as well. So let's say I want to access the third value, which is index 2. So I just put in 2 into the square bracket instead. So I just print my list 2, right? So the index here, instead of 0, I put 2, and it will access the third value of the list, which is 2. Okay, so and lastly, this variable, this indexed list, right, it can act as a variable as well, so you can perform arithmetic as well. So like if I want to do print my list 0, right, plus my list 3 times 2. So this index 0 is the value 1, right? So it's 1, and then index 3 is the value 3. So it's 1 plus 3 times 2. So if I enter, I get 7. So you can do arithmetic with with list items, just like how you do arithmetic with variables. And in fact, the list items, they act exactly like variables. So if I do my list 0 equals to 2, then I'm saying the first index, right? I'm saying the 0th index, which is the first slot over here. I'm saying replace the current value 1, assign it the equal sign to the new value 2, or whatever's on the right hand side. Press enter. Now if I print my list, and I get, you see that instead of having 1, 5, 2, 3, I get 2, 5, 2, 3. Okay, so the upshot of this is that lists are essentially many variables, just that you can access them via this indexing system. And if you want to access the nth element, it'll be corresponding to index n minus 1. Okay, so yeah, so one more thing is that what if I have a very long list, and I want to count the number of variables? You can use something called the length. So this length, right? So if let's say I have a long list over here, let me just clear the output. So let's say I have a long list over here with the values 3, 1, 4, 1, 5, 9, 2, 6. Okay, so let's say how do I easily find the length of the list? So you can do so via the function length. So length of new, so you write length and then you open with round brackets and then you put in the list name inside. Okay, so if I want to print this out, then I do print sandwich this length of new list in the print round brackets and I get it. So essentially this is saying print the value inside the brackets, right? What's the value inside the brackets? It is the length of the new list, which is going to be 8. Okay, so yeah, so using this, you see that if let's say I want to get the last element, right? What's the last element? So the last element is the 8th element in this case, right? Because the length is 8. So it's first element, second element, third element, so on, and the last element is the 8th element. But remember that the 8th element is actually index 7 if I want to access it. So what this will mean is that so what this means is that if we want to access the last element, we need to find a way to write the index 7. Okay, and this index 7 comes from 8 minus 1. So so we will be writing, if you want to access the last element, we'll be writing this. So we put in the square brackets, right? What do we put in the square brackets? We write the length of the new list, minus 1. So what this means is that this one over here is going to be value 8, right? So 8 minus 1 is going to be value 7, and then I'm accessing the list index of 7. So if I press enter, I get the value 6. So so you may be asking, how does this differ from just doing this, right? Because isn't the 7 easier to see? Well, the answer is that if you want to access the last element of a list, then what if the list has a different length? So if my new list now has a length of, let's say, 10, okay? So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then how do I access the last element? Clearly, I cannot use, if I use new list 7, it's just going to access the 8th element, right? And that's not what I want, because now the length of the list has changed. So it's no longer 8 minus 1, which is 7. Now it's actually going to be 10 minus 1, which is 9. So if I write new list 7, it doesn't achieve the intended task of accessing the last list element. But if I write length of new list, right, minus 1, then you realize that length of new list is now a different value. It's not 8 anymore. It's going to be 10. So 10 minus 1, you get 9, and you access new list 9, which gets you the correct value of the last element. Okay, so that's just I hope this has been not too confusing for you. But yeah, basically what this is trying to say is that, what if I want to say, instead of taking the let's say the third element from the left, what if I want to take the third last element from the right, right? So then you use the variable called you use the function length, you use this length to put in the variable, the list name inside to calculate it. So Python actually does this for you. So if you put in a negative index, then it's going to interpret it as, it's going to insert in for you the length of the new list. So basically, if you want to access the list, right, so in the second row over here we have the normal index, and then in the first row over here we have the index going in reverse order. So this is index minus 1, so on. So you see print, so instead of typing, Python makes it simple such that instead of typing instead of typing new list, instead of typing length new list minus 1, instead of typing this whole thing, you can just write new list and you just write -1, and Python will automatically interpret the negative index as putting in the length lineage. So if I do this, I just get 6. So yeah, so this is a way for you to go in reverse. Okay, so what can you do? What else can you do with a list that we don't know yet? We can add values to a list, right? So if we write if we have an existing list right now, let's create a list with the name short list, and we have values 1 and 2 inside. So print short list, we just get 1, 2, and let's say I want to add a new element to the end of it. So I'll use the append command. So I write short list dot, right, full stop, append, and I'll open round brackets, and inside this round brackets I'll put in the value 3. Okay, so if I print short list again, now I get 1, 2, 3, right? So I hope that's clear enough. And we can also delete elements. So let's say I want to delete the second element, right? Second element, which has which is this number 2 over here, which is this value 2 over here, and I want to delete the second element, which means that I want to delete the first index 1. So I'll write delete short list, and I put the index over here, and if I print short list again, now I see that the second element, which is corresponds to index 1, has disappeared, and now the list is only 1 and 3. Okay, and lastly, I can also sort the list. So let's say I have my list equals to 4, 6, 2, 1, 3. Then if I print sorted, or if I want to sort the list, I can use the keyword sorted, and I write the variable name inside, noting that I have used capital L, right? And if I write this, then I get sorted my list, and you see that it helped me sort the values. Yeah. So those are just some stuff that you can do with lists. There are many other things you can do, but these are the main important ones. So you see that with lists, we have quite a lot of power in that we can generate many variables, right? But what if I want to, one useful thing to use in conjunction with lists is for loops, because a for loop can help you access all the values of the list at once. Not at once, but one by one. Okay, so for loops is a way for you to repeatedly do something. So let's say I want to append the value 5 to a list 3 times. So what would it look like? Okay, so over here now we'll be writing code in the editor, right? We will no longer be writing code in a console. So let's say I have a list called 1, 3 with the values 1, 3, 2. Okay, so if I print my list at the moment, then I'm going to get 1, 3, 2. Okay, but let's say I want to append the element 5 3 times. So one way I could do is write this, right? And then I could copy this 3 times, and I print my list, then I'm going to get the value. So you see that the first print sign over here, this one was this one, right? So this one was, the output is this. Then after appending 3 times, now my output is no longer the same. Now my output is the new list over here with 3 additional 5s behind. Okay, but how do I do this? What's a more efficient way to do this, right? So instead of writing so many lines, I can write a for loop. So if I want to do something 3 times, I write the keyword for I in range 3, my list dot pen 5. Okay, I don't know why my color editor is not working. Oh, I think I need to log in. Okay, let me just log in. Sorry, I'm just logging in because I want to be able to yeah, because I want to be able to get the color coded editor. So okay, sorry for that. Let me just, okay, now the annoying thing is that I cannot have a up and down. Okay, anyway, it's fine. So if I repeat L dot, sorry, I'm just trying to find a way to okay. Can I have color coded editor while having I guess probably not. Layout stacked. Okay, that's wonderful. Okay, that works. Okay, so now if I write code like that, then I press run, and you see that so you see that it achieved the same function. So it has appended the value 5 to the list 3 times. Okay, so we see that it works. Okay, so that's what for loops. For loops, first of all, now we learned that for loops are a way of doing something repeatedly. So let's dissect what actually goes on inside a for loop. Okay, so if we go through, so let's say we print before the for loop over here, then we write a for loop, right? So for I in range 3, and so what is this I over here? This I is a variable, this is a counter, the I over here is a variable that Python would help us create to count, to keep track of the iterations inside the loop. So if I print inside the for loop over here, and I print the value I, right? Let's see what goes on. Okay, so print after the for loop. So in this case, I'm using the print statements as a way to keep track of how the program runs and the procedures that it takes to run the code. So if I see over here, it starts off with before the for loop, and then it prints. So the first line is before the for loop, right? Because Python goes through the first line and it prints this goes through this statement, it prints for loop. Then if I write, so it goes to the first iteration of so now it goes into the first iteration of the for loop. So it starts off this line, so it goes into the for loop and it goes print. So it starts off with the value I equals to 0. So now the variable I stores the value 0 and it enters this for loop. Oh, and I forgot to say, sorry, when you write a for loop, right, this space over here is called indentation. So you press enter and you press, if it's like that, then you press tab, right? You can write 2 spaces as well, but you need to be consistent. So you use the tab space. Okay, so anyway, we are inside the for loop and it does print inside the for loop, which is what we see over here. Print inside the for loop. Then the next line over here, it prints the variable I. So remember that now I has the value 0. So it prints 0, okay? And so after it goes to the end of the, now it has reached the end of the first iteration of the for loop, right? So it goes all the way to the top to line 4 again, goes to the start of line 4, and executes whatever is inside the block of the for loop with the value of I incremented by 1. So so it executes this, print inside the for loop, okay? Then it prints the value of I, which is now has changed to become 1. Then it goes, so now it has reached the end of the block again, and then it goes to the beginning of the block, and now it increments the value of I to be 2. So then it prints inside the for loop, which results in this output, and then it prints I, which results in the output 2. So the upshot of this is that okay, then after that it reaches the end of the for loop, and because the for loop only iterates 3 times, now it no longer increments the, now it no longer runs the for loop again, and it exits the for loop, and it continues the rest of code, in this case print after the for loop. So I hope that this snippet over here clearly illustrates what goes on inside a for loop, and yeah, so in summary, when you have a for loop, right, it is, with a for loop you write for I in range 3 and you write colon, then you use the indentation to demarcate whatever happens inside the for loop, and inside this block of code it will be executed a few times, and how many times it will be executed is dependent on the value you put over here. So in this case I write 3, so the inside of the for loop will be executed 3 times, and the counter, the for loop will also help us keep track of how many times the loop is executed with the variable I as a counter. So it starts off from 0, right, for the first iteration. Then after the first iteration, it goes to 1, goes to 2. So the variable I will take on the value 0, 1, 2 sequentially with each iteration of the for loop. Yeah. So let's go ahead. So that's how the for loop works. Yeah. And so if we see that using the for loop and using the variable I as a counter, we can keep track of more things that goes on inside the. You can do stuff. You can do more stuff with the. We can do more stuff with the for loop. So for example, instead of just printing I, which is quite boring, let's say we print 3 times I. Okay, so we press and we execute the code over here. Press enter. Then we see before the for loop, right? When we see inside the for loop, then the first iteration I equals to what? I equals to 0, right? First iteration I equals to 0, so 3 times 0 is 0. Then the second iteration I equals to 3, so I equals to 1. Then 3 times 1 it gives you 3. Then the third iteration I equals to 2, so 3 times I gets you 6. So we see that with the variable I inside the for loop, we can do mathematical manipulations over here, and yeah, so I is a variable that we can really play with, right? We should not change the value of I, because Python automatically keeps track of the value of I for us, and we might confuse it if we try to play with the value of I. So it's bad practice to change the value of I. So we should not write something like I equals to 1. That will be not very good. Okay, but we can access I, we can view the value inside I. So if write I times I, press the run button over here, then we see that now it goes inside the for. So before the for loop, first line, then it goes inside the for loop. Then it prints for the first iteration where I equals to 0. It prints the value 0. 3 times 0 is 0, and 0 times 0 is 0, right? Then it goes the next iteration of the for loop inside the for loop. Then I equals to 1, so 3 times 1 equals to 3, and 1 times 1 equals to 1. And then the next iteration of for loop I equals to 2, so 3 times 2 is 6, and 2 times 2 is 4. So that's why we see 6 and 4 in this case over here. Okay, so then we exit the for loop, and we see it prints after the for loop. Okay, so we see that the value of I takes the values. So we see the variable I takes the values 0, 1, and 2, right? Which is a total of 3 numbers, right? But what if we don't want it to take 0, 0, 1, and 2? Well, we can also use the range start and end. So for example, if I have a for loop over here, for I in range 2, 5. So same syntax, I write the keyword for, and I write the variable name to keep the counter variable, to keep track of the iterations, and I write in, and I write in range. So range, it generates range basically generates a range of values. So in this case, range will be the values 2, 3, 4. Okay, so if I print I, and I print I squared equals to, okay, so if I want to print multiple values, I will separate them with a comma, right? And I write I times I. So that will give me 2, that will print, so in the first iteration I equals to 2, right? So I takes on the values 2, 3, 4. So in the first iteration I equals to 2, so that will print 2, 2, and I print this words over here, and print 2 times 2, which is 4, right? And then the next iteration I takes on the value 3, so it will print 3, it prints these words over here, and it'll print 3 times 3, right? And the next iteration you take on 4, which is, you print 4, then it prints these words over here, and you print 4 times 4. So yeah, so if you don't want the variable I to take on 0, 1, and 2, and you want to start from arbitrary numbers, then you can use the range start and end. So what is for loop particularly useful for? It's useful for accessing list elements. So in particular, if I have a list called by list, it goes to, let's say there's some values inside here, and let's say I want to access the elements of the list, right? So I can write a for loop. So over here, I want to access all elements of the list. So this for loop needs to run how many times? It needs to run the length of the list. So I write length of the list over here. So in this case, length of my list is going to be 6. So this is effectively writing for I in range 6. But I'm just writing length from list so that if we change the value, if you change the length of the list over here, then the value of my length from my list would correspondingly change, right? And we can still access all elements of the list. So anyway, so we write the colon and we write and we leave an indentation over here. We print the ith, right, element is my list I. So you see over here is over here I takes on the values. I takes on values of 0, 1, 2, 3, 4, 5, right? Because this is a range of 6, right? So it takes on 0 to 5, and the clever part of this is that because 0 to 5 are precisely the indices of these items, we print this, you can see that it goes sequentially. So it goes 0 and it prints the 0 element is, and it accesses my list 0, which is 1. Alright, and then it goes on, so the 1th element 1 and is going to be my list 1 with the list with when I takes on the value 1 is going to be 1 inside here, and it's going to access this guy, so it's 3. So it goes on, and that allows us to access all the elements of the list using a for loop. So this is a way to, what we say, iterate through the list. Yeah, so basically you have a list of values and you want to go one by one through the entire list of values. So using this we can do many things right now. So for example, we want to double all the numbers in the list. We can iterate through the list, and for each item in the list we say this current element, I want to set it equals to itself times 2. So this is just like saying x equals to x times 2, in the same sense that it's assigning the new value on the right hand side to the variable on the left hand side. So we see that initially is 1 3 2 0 minus 1 2, right? If we go through after this code, we print my list, it's going to give us 2 6 4 0 minus 2 4, which is double. Each element is double of this whatever is inside here. So with this, one simple thing we can do is generate the Fibonacci sequence, because remember that the Fibonacci sequence is defined as the recurrence relation of fn equals to the last element plus the second last element, right? So if you want to generate the Fibonacci numbers, we have the first two elements we define as 1 and 1, right? Then after that we just append. We do this 10 times, right? We write a for loop to generate 10 additional numbers, and for each one of those we say the Fibo, we add one more element to the last part of the list. And what element does it add? It adds the last element plus the second last element. If we run the code here, we see that it will generate us the Fibonacci sequence up to 12 places. So list can also so for loops can also be nested, in the sense that you can write the for loop within the for loop. So if we do this, we write for I in range 2, right? So I goes from 0 to 1 inclusive, and for j, so inside this I for loop, right, we see that this part is indented. So for these two lines, the second and third line over here is inside the block of the first for loop. So then if we see this code, it says for j in range 3, so j goes from 0 to 2. So if we print I and j, right, then you run the whole thing, total of 2 times 3 equals to 6 times, and for each one of those iterations you're going to see so for the first iteration of the I loop, you can see 0 0 0, right? And then we're going to see the corresponding values 0 1 2, right? And then it goes it finishes the first block, so it goes all the way up again, and it goes and out. Now I takes the value 1, and it'll output 1 0 1 1 1 2. So it's okay if this slide is very confusing. It's fine if you don't understand this slide particularly. I just want to bring to your attention that there is such a thing as nested loops, and in fact it's quite powerful. Yeah, so you can see that you can generate things like a multiplication table, right? So For example, if I want to generate a multiplication table, I just have one for loop for the first variable, second for loop for the second variable, right? And I can do the first variable times the second variable equals to, I just print the following statement and I do I times j, and you can see that it has generated a nice multiplication table for me over here. So with just 3 lines of code, I can generate a multiplication table up to almost any number you want to imagine. So that is the power of nested for loops. But it's okay if this part is confusing, it's fine. If you're not comfortable with 2 for loops in succession, then you can just play with 1 for now. Yeah, so I'm actually running out of time. So I'm going to not give you 5 minutes to do this, and instead I'm going to just go through it immediately. So right, let's see the first exercise. The first exercise is to write code to output meow 30 times. So I recommend you take a look at these exercises at home, but I'll be just speeding through them right now. So the first assignment is to write code that outputs meow 30 times. So this is simple enough. You just write a for loop, range 30 to indicate the number of times you want to iterate, and you print meow. And if you see, it just prints so many times. Yeah. So second exercise is to write code to generate the first 10 even numbers, right? 0 included. So we can write for I range 10, right? And now I will take on the values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you want to generate so now I takes the values 0 to 9, right? If you want to generate the even numbers, you just take 2 times the value of I. So if you do this, then it will sequentially output 0, 2, 4, 6, and we see that we have successfully generated the first 10 even numbers. So if you want to generate first 10 positive even numbers, which means that we exclude 0, there's 2 implementations to solve this task. One is, instead of writing I times 2, you just write I plus 1 times 2. So basically the first guy, which would be the first iteration, which is I equals to 0, which I takes on the value 0, it will be 0 plus 1, right, inside the bracket, which is 1 times 2, which is 2. And then from then on, I would be iterating more and more, higher and higher, and instead of generating 0 to 18, we generate 2 to 20. So that's the first implementation. But you can do it exactly in another way. You can do for I in range 1 to 11, right? You need to do 11 here because the I will not reach 11. Basically, it goes to whatever is in the second place over here minus 1. Yeah. So it print I times 2, it generates the same output. So lastly, let's generate the first 10 squared numbers excluding 0. So we can just replace the block inside the for loop with I times I instead of I times 2. So that generates the first 10 squared numbers, and yeah. So anyway, we're reaching the end of the video. So I try to keep it under 1 hour. So I want you to write code to take in the I want you to write code to take in the user's name and birth year. Actually, I haven't taught inputs yet, but I haven't taught inputs yet, but okay, it's okay. Just store it in the variable name. So I want you to. This is exercise for variables, right? The second exercise is an exercise for for loops and variables, and the third exercise is exercise for loops, right? And the fourth exercise is exercise for even more for loops. So anyway, I've reached the end of the first lesson. Okay, before that, right, I know I've stated I've said that you want to take the user input over here. Okay, I'll be removing these in the actual slides, but because I haven't taught user input yet. But okay, anyway, it's the end of the first lesson, and I want to wrap off by saying that coding is a skill you learn by performing it yourself, and it's impossible to say that you can say that you know coding if you have just learned the theory and the content, but only through practice will you really meet new bugs and be able to write code that does something useful. So I really encourage you, if you want to try this out, to just try coding by yourself. And you may be thinking, oh, but I'm all by myself, right? But actually it starts off that way. So you just need to get your hands dirty and try it out, and if you meet errors, then that's what I'm here for. So I want you to go out and try coding, and if you meet like bugs, right, if you see an error, just take a picture, send it to me on Telegram, and I'll talk to you directly and help you. And that's what I'm here for. I'm offering free help for coding. And basically resources are abundant on the internet, that so that there are actually many, if you want to achieve any task using coding, there's actually probably already a resource out there. And but so resources are abundant, but the skills are where you need to, the skills are the things that are difficult to pick up, to be able to understand these resources. And the only way to try to do that is to try it out yourself. So it's okay if some of you are just trying it out, and after the first lesson you realize, oh, variables, who are those things, I've completely lost interest, and if you don't want to come next week, it's perfectly okay. I'm fine with it. So but may I suggest that you just give it a try, and it'll be more fun. I assure you that it'll be more fun the more you know. Currently it may seem dry and boring because all you know is how to store values in variables and maybe list of them, but if these are basic building blocks that if you know them, if you know more building blocks, then you can build more interesting behavior. And in fact, if you want some more examples, I can definitely give it to you lah. So you can build things like a calculator, you can take in user input, right? So it'll be a program that asks you, do you have this, give me a number. Then like maybe you can create a guessing game, or you can create some text-based game, and you can even create, you go on further, you can even create like graphics, right? You can create computer games and stuff like that. So I suggest that you at least give it a try, and maybe stick on for 3 lessons. But if you really lost interest, it's completely okay. Yeah, that's understandable. So anyway, see you next week. And yeah, next week we'll be talking about functions. But yeah, that's the end of this video. Thank you.